All right, welcome everybody to today's Spatial IQ for MapGeo webinar presented by Sanborn. We are talking about unlocking insights from imagery and Lidar data. A couple of quick logistics before we get started. This webinar is being recorded. Everybody is currently in listen-only mode. There is a box down in the bottom section of the Zoom for questions and answers. So if you have any questions throughout our presentation, please throw them in there and we'll take a look at those at the end of our presentation today. Quick background on what Spatial IQ is and some of the benefits. So Spatial IQ is a managed services program to help improve your GIS programs for your organization and to build onto the MapGeo platform, which is one of our products known as the parcel data viewer. So some of those benefits include annual geospatial data updates. So that's keeping your foundational data such as parcels and zoning, addresses, things like that up to date. We also offer GIS help desk support. So if you've got a question about something that you're working on and you just need a little bit of support, that comes as part of the Spatial IQ package. We also have hosted data that you're allowed to have on MapGeo, and you can have any data you want on there that can be downloaded, whether that's available to the public or just for internal use only. We also provide an annual overlay theme on MapGeo every year. So the example down in the bottom right corner for our alternative fuel stations was our latest overlay that we had added last year for folks. And the other big thing that we do is a strategic planning meeting that kind of goes over some of the needs and wants that your department organization has for that current year. And we kind of get everything laid out, give a game plan, give some budgetary estimates for some of those projects that are discussed in that meeting to kind of give us that direction for the year. Certainly, as other things come up, we discuss those when they happen, but also these webinars are included as part of that package. So today I am joined by two of my colleagues, Chris and Carson, so I will let them introduce themselves.
Hi, everybody. My name is Carson Bellino. I'm a project manager at the Sanborn's App Geo division. I am primarily working with a lot of spatial IQ clients, mostly in the New England area, as well as helping out on the enterprise data build-outs, as well as a couple of other projects that are related to this discussion around imagery and LiDAR. So we'll share like a little bit of that with you. So, Chris.
Yeah, sure. Thanks, Carson. My name's Chris Genovese. I'm a customer support engineer here in the AppGeo division for Sanborn. Currently, I'm working on several different projects that revolve around the topics that we're talking about. So I'm pretty excited to get into this. Carson, why don't you?
Awesome. So today's topic, we have about 3 parts for you today. We're going to start with an introduction and discussing imagery, where we go into kind of the basics of it, some things that get derived from it, some products, and then some use cases. And then I'll hand it over to Chris, who will discuss similar things for LiDAR. And then we're going to bring it all together and discuss some combined use cases where we're leveraging both imagery data sets and LiDAR to produce some really fun end products and meet some really interesting use cases. Once all that is done, we'll then have a quick Q&A at the end where we can answer any questions that you guys may have. So first, we're going to jump into a quick audience poll and just kind of gauge where people are at, where they're coming from background-wise, and if they have captured any imagery or LiDAR recently, maybe in a 2, 3, 5-year span, something kind of anywhere in that kind of range. So I think Rebecca might be sending that out, and we'll give it a second, and then we'll kind of keep it going.
You guys should see that now on your screens. Answers are coming in. We're already over halfway through, so we'll give it another 30 seconds. All right, we seem to be holding steady there, so I will end the poll and then everybody can see the results. It'll come up as a pop-up, so when you're done, you can just close those. But we have 58% that said yes, they have had imagery or LiDAR captured for their organization, 28% no, and 14% I'm not sure. So let's get into that.
Awesome. So it sounds like we have a pretty wide variety of stages here, which is awesome. So let's jump into imagery itself here. Let's see if I can get this advancing a little bit. And we'll talk about, the basics of what is imagery. I think probably most of you are familiar with an image of some sort. What we're talking about here today is a little bit more specified and standardized for that. Generally, we follow some standard precision, accuracy, resolution requirements, and things like that. And we're deriving this imagery from a number of different sources. So that can be either from a drone, for more smaller scale, more continuous, frequent flights. Primarily, what we'll be discussing is imagery in Lidar derived from aerial airplanes, as you can kind of see on the right-hand side screen. And then there's also satellite imagery as well, which we won't be talking about too much today, but we'll be happy to answer any questions. So what imagery is in this context is really high quality imagery that has, a certain resolution scale, accuracy standards, and using that, we're able to rectify a series of images collected from an airplane to create a nice little mosaic and bringing these all together, correcting for any issues in maybe warp or inaccuracies, stitching it all together and creating this nice final product that you're able to utilize a lot of these great functions that we'll discuss. Just wanted to kind of take a quick step back before we jump into, jump into it and discuss resolution versus accuracy, as that's something that's going to come up a little bit during this discussion. I'm sure you're all familiar with accuracy from the discussion on like precision and accuracy. Accuracy is obviously getting as close to that target center as possible. And in this case, it's no different. It's basically what we would define as the closeness to the real world. So when you have this nice final product and you're looking at imagery from an aerial view, you may see something like a manhole. If you were to go into real life and take a very highly accurate GPS and stand on that manhole and take a point of that with the GPS, and if you were to bring it and overlay it into the imagery, would that point fall in the center of the manhole? Would it be on the side of it? Would it be 5 feet down the road? That's what we're talking about where we're talking about accuracy. So it's a positional accuracy. Are you off by 1.5 feet, half a foot, a couple of inches, all of that. Resolution is a little bit different from precision that you might be familiar with. It's not really like a decimal place. It's more of the resolution or level of detail. So we're really talking about distance per pixel, a foot per pixel, inches per pixel, 3-inch is a pretty standard, 6-inch, things like that. I think a lot of us are familiar with maybe CSI, where you have an instance where they're looking at some crime footage on the CCTV camera and they say enhance, and then you zoom in and it becomes magically clearer. That's not really the case here. Resolution is something that you kind of have to specify at the outset. And obviously, these are things that are specified at the flight, accuracy, resolution, following things like ASPRS standards and things like that. So obviously, they're all tailor-made to what the flight is trying to achieve. High resolution is going to be more expensive. Lower resolution, lower accuracy is a little bit more cost-efficient, but it may not give you exactly what you're looking for. So with that in mind, we'll plow ahead and start talking about the types of imagery. We're going to talk about really basic types of imagery here, nothing too intense, and just kind of extrapolate on all the wonderful use cases that you can derive from these. So on the left here, there's ortho imagery. It's imagery that you're probably all very familiar with. It's that top-down nadir approach. So it's the point that is looking directly down from, in this case, an aerial plane that's taking this imagery. So all this is stitched together. There's the plane's obviously taking numerous amounts of photographs, and they all get stitched together so you can start panning around. You can see a top-down perspective wherever you go. Oblique imagery is a little bit different. If we come back to this diagram here on the right, you'll notice that you can see in the plane image that on the ground there are these purple, blue, green, yellow areas. And these are the areas that are capturing oblique image. And what it's really capturing here is kind of a 45-ish degree angle. So if we come back here, you can see we're getting really the front face of the features and the buildings here as compared to ortho imagery. And another wonderful tool about oblique imagery is when you stitch these all together like you do for ortho, you have a complete side of all these. So as you're grabbing all those different perspectives from that diagram that I showed, you're able to kind of rotate around the surface and see different angles of everything from your oblique imagery, which is a really powerful tool. And we'll talk about kind of how that gets used in day-to-day tools and things like that in a little bit. So we're just going to talk quickly about imagery band breakdown. Basically, imagery is composited from a series of bands that get composited together to create an output. In this case, you can see some pretty standard RGB colors coming together to create a true color. So this is what we call three band. Typically represents the visible light spectrum. That's why you have your R, red, green, and blue, which is what makes up the natural colors that we see in human perception. So in the bottom left hand here, you can see a pretty standard aerial shot. The trees are green. The man-made features are concrete and or dirt colored if you look at the baseball fields there. So it's pretty much what you'd expect to see if you were to look out the window right now. Most digital captures and flyovers in this day and age have four-band imagery where you're capturing this fourth band, which is near infrared. I won't get into what exactly that is, but essentially what can be used is we can utilize that near infrared wavelength and assign it to one of the colors, in this case red, to create a color infrared or false imagery output. So you can see in the right here, this is a color infrared CIR output where we've taken that near infrared, replaced it with the red band that was on the left, and you can see that it really pops and accentuates the vegetation. So very any healthy vegetation comes in this nice, really deep, rich red. And you can see kind of less healthier areas kind of in the top right there on the baseball fields where some of it's kind of kicked up. It's got less density. It's less healthy. It's a little bit grayer, a little bit browner. So this is a really good way of identifying features that have vegetation as a basis. So this is and clearly defining between that and man-made items as well. So really powerful tools that we can use here. We're going to talk about some use cases. Some of these are a little bit products. Some of these are use cases. By no means are these all of the use cases that you can use imagery for. There's a huge amount of them that can be discussed. We'll be discussing some of them more in detail later when we combine them with Lidar, but some of them can be done without Lidar. Some of them just get a lot more information. There's a better context for Lidar. So don't think that these are all the use cases that you can use here. So first one, outputting digital elevation, digital terrain, and digital surface models. I'm not going to touch on this too much because Chris is going to give us a really great in-depth look at some of these in the LiDAR perspective, but essentially where you're capturing all this GPS, flight telemetry, what angle that the plane is at when it's flying, what position is it in relative to the ground, you're able to gather a lot of information that is stored in these imagery files as well. So we're able to composite an elevation, showing what the elevation is. We can bring out and break out terrain, and then we can also do surface models. So I'll let Chris kind of discuss that in a little bit more detail later. A really powerful tool that a lot of oblique and just series of imageries are being used for in the assessing world, which I know some of you are part of, is being able to review and measure things. So in this case, you can see in the top left, this oblique analyst is being it's got tools in it that allow you to measure the slope, the height, the length, and all these different assets and features of assets from oblique imagery. So obviously you're coming in at that 45-degree angle, so you're able to see these great shots of the side of the wall, and you're able to kind of pick up key details and kind of confirm things. So this can be really helpful for assessors or any department if they're looking into changes, maybe unsanctioned changes. They can kind of look between years and see, oh, is this actually a 2-foot thing that they've added, or if they added extra. Same thing on the right here. If you have multiple ortho imagery years, you can use that to kind of see change detection. On the right here, we have kind of a more sanctioned build out where Molly Town Road here in 2014 on the top was just kind of the pavement had just been laid down and there wasn't any houses built yet. And then you can see in the intervening years up till recently, all of those wonderful homes have been built. So this is a really good way of checking how things have been developing. It doesn't have to be man-made items. It can be vegetation, water level lines, things like that as well. So this is a really powerful tool. And I think something that's understated in this is how it can be used for kind of making improvements, kind of showing what you want to convey, maybe in between departments, to your constituency, to a stakeholder, to anybody, having that visual information that you can really zoom into, show changes over time, show how things are operating down in the field, can really help you sell something that you're trying to, get approval for, get funding for, et cetera, et cetera. So really attaching that human world context in that spatial reference can be really powerful. Another one that we use is planimetrics. So we're pulling a lot of data together. You can pull contour data out of that elevation models and things like that and generate a lot of really interesting and unique and really strategic data here. And then that can all be, put together in stereo to create some really important maps you can see in the bottom left, where we're taking the imagery, we're overlaying the contours, and then a lot of other base utility features. I think this is a drainage feature here, as well as the parcel layers. So we're getting a lot of key information. So that's a really great final kind of use case and product that you can really leverage. So having these maps that have a really rich and really full amount of information, also backing an aerial, image, can be really helpful for that context that I was just kind of alluding to earlier. So, Chris, if there's anything you want to talk about for imagery before I hand that off to you and we can start talking about LiDAR, please go for it.
Yeah, no, I think you did an excellent job, Carson. I mean, there's just so much you could do with imagery. I think it's an invaluable tool.
Awesome. Well, I will kick it over to you to get into LiDAR.
Sure. So I'm going to kind of follow the same format here, kind of go into LiDAR, kind of open up LiDAR in terms of what is it and how does it function, and what can we really do with it, and how does it how is it utilized, and then we'll get into those kind of use cases, and where is the overlap between what you could do with imagery and what you could do with LiDAR, and how do they kind of complement them, each other. So all right, so what is LiDAR? So LiDAR is basically just a way to, gather data using light beams in essence. So, it's basically just shooting laser down to the earth from, depending, obviously, we're going to talk mostly about aerial type collects. So, flying your plane along and, getting the information as you're going along. There's several different types of LiDAR, but we'll kind of just stay with the general type that we're talking about here. And kind of one thing to note, if you look at the kind of diagram there, one of the aspects of LiDAR is it'll bring up multiple types of information, and one of those is how many returns. So in the case where there's an unobstructed line of sight from the sensor to the ground, there's basically one return, and that will be called our first and last at the same time. So it's going to be the same. In a case where the light pulse is going through several different things, such as the tree, we might get multiple returns for that same light pulse. So, therefore, we're kind of building up additional data regarding any one particular object. And, that's really very, very valuable data when we try and extrapolate through that. Okay, let's see, what do we got next? So one of the additional things about LiDAR is we're not just sending a little beam of light down and collecting that, but there's a whole bunch of other bits of information that relate to that. So, the reflection that comes off any particular object is going to be different. So if it's a dark object versus a light object, color versus black or white, all of these things are going to return different bits of information. And all of that can be used again later on as we go through and we try and process and to understand what it is on the ground that we're actually looking at. So a lot of these things, the terminologies of amplitude, intensity, reflectance, and all of these different bits of information enable us to look at different things, dirt or rock or trees or buildings and things like that. So, okay, next slide here. So, as Carson had talked about, like, accuracy and things like that within imagery, right? We're talking about pixels and, the accuracy there. In LiDAR, we do have, the accuracy, of course, we're talking vertical and horizontal, but we're also talking density, how many points, and it's usually points per square meter. And typically these days we're probably at 8 or more points per square meter. That could go certainly up much higher. And, the more you have, the better kind of the fidelity of the data that you could get out of that. And the next slide here kind of gives you a little bit of idea. These kind of QL levels, that kind of dictates a little bit of how many points per square meter, and from that also accuracy, vertical accuracy, things like that. So the denser the points per square meter, that overall cloud of data, the better you can distinguish different objects from each other, and certainly, smaller objects. So the next couple slides, just going to kind of go over a little bit of visualizing some of the information within LiDAR. So this is, it's kind of, to the human eye, it's a little difficult to see, but, just kind of showing you, the white area is really direct line of sight. So, it's really saying, okay, here there's a first and last return is pretty much the same thing. And a lot of that's going to be more of your man-made type features, right? Your roads, plowed fields, buildings, things like that. Where you get into more of the vegetation and things like, those types of areas, trees and shrubs and other things, you're going to have multiple returns for any single location. And that's kind of where you're seeing these reds and greens and blues within the picture. So those are the, intermediate and last returns from some of those objects. Okay, what do we have next? Okay, so intensity, like I said, depending on, what the object is and the coloring, you will get varying levels of intensity back from that. So the LiDAR, sensor is going to return and store those values also. So, things like, black roads versus the grass areas, these are going to have different returns. Same with like roof types. You could discern some of the buildings might have, kind of like the parking garage that Carson was highlighting there. That's going to have one return versus something that might have a white gravel roof. So these things will, again, give us more information as we go through trying to discern what those objects are. Let's see, next slide here is pretty much what you would consider your standard objective out of LiDAR. What is the height of everything, or that elevation for these features, to understand that. And we're going to kind of break this down a little bit more too as we go forward. But, and again, every object might have different returns on it. And so trees and things like that, we're going to take, the first return, which will be kind of that highest elevation for those trees. And then kind of taking all this information together, we could start breaking it out and classifying what are these objects, right? So we could have some, roads, our trees, our buildings. Maybe we're going to classify that out in different ways later on, but this is kind of like that first cut in terms of what a classification scheme might turn out to look like. So like I said, elevation, and, Carson was talking about this too with imagery, right? We get our DEMs, DSMs, and, all this terminology. It's really good, but basically this is a way to visualize data in a real world sense of, what are these elevations and heights of different features that we have, within the data. So I kind of put together a couple slides here to show the difference between some of these things. And I thought, these kind of really gave a good example of this. So, your DSM is really, what's the height of all the objects within, my scope here, whether it's a building or a tree or, a car, even as is shown here, versus the DTM, which is our terrain, the actual ground underneath everything. And, both of these have, really important uses. And then there's what we call an NDSM. So we're normalizing our height of objects. So we're kind of taking the surface out and saying, okay, let's just flatten that. And then, what's our height of all the objects that we have within, our model here. And these get utilized in different ways, again, as we kind of go and extrapolate data. The second thing I wanted to throw in here was a canopy height model. And when we're talking about urban forestry models and things like that, these are, models that are very, very useful to bring about this information and create these other additional products. So, again, this is similar where we're taking the DSM and DTM, and then we're creating, just the height of vegetation. So in the other model, NDSM, that's everything, including man-made. Canopy height is only for the vegetation type data. So, we have a couple slides here that are just going to kind of show, what does that look like within the actual LiDAR data. So, here we have a DEM, and again, this is the, surface. So in here, you kind of able to see, okay, I got a river down there, got a mountain on the right, and there's some, kind of roads going around the mountain. So this is very good to show a lot of detail that's on the ground surface. And if you look up on the top right, you can kind of see there was a little landslide that, kind of went off the mountain here. So, really, really detailed and valuable information that you could obtain from LiDAR in this sense. And obviously, the more points per square meter, the smaller the types of objects and, the definition within what you can see. So the next slide here, the surface model. So now we're adding in kind of the objects that we're seeing within the area. So now we have our trees and things. So now you can notice that landslide and the roads are kind of hidden. You can't really see it quite as well. There's slight scarring in the tree canopy there. But for the most part, you're not able to see that type of data. So when we move on to our NDSM, in this case, what you probably notice is it looks very similar to the DSM. However, where the kind of river was flowing, that kind of got flattened out. So you're not really noticing that quite as much. So if we looked at this on its side, if you remember the previous slide, the surface area is flat. So that's why that river's kind of muted out, and all we're seeing are, the man-made and or vegetation objects. There's one small building kind of in the middle all the way to the side there. So you will notice that has the elevation attached to that. And if we move to our next slide, which is the canopy height model slide, again, this is very similar. That structure is kind of muted out and down to the, a little bit down more towards the surface. So, the objective of this, again, is just to show more of the canopy. Okay, so we have all these cool things. What can we do with this type of stuff, right? So that's the real objective here. So, One thing is obviously, looking at water and, how does water flow, and building drainage basins and flow models, and very important type information, especially when you're, trying to model out flooding and things like that. On the right side, there's, kind of an urban area. There's some FEMA flood zones in there. So trying to understand where is the water coming from, and how, where is it flowing out of that area, to try and understand, where can mitigation occur if it can, and things like that. So, this type of information is one of the top use cases, I think, for LiDAR. Just because the accuracy of and density of the information really lends itself to being able to figure out where those stream flows are going to occur. Let's see, what do we got for our next one here? So buildings, obviously, many people have buildings. Probably most are in the two-dimensional aspect. Again, Carson, with the imageries, showing buildings, that could certainly be brought from imagery via planimetrics. We could create, very accurate, high detailed footprints, as well as 3D models. But taking some of the existing data and merging it with LiDAR, we can enhance existing structures. We could also just create, footprints from that LiDAR as we classify the data, and kind of extract out those building footprints, and, try and get, due to the density of the points, really able to get slope and kind of break down those roofs of structures. And that could help with, a lot of different, modern applications, such as, analysis for solar implementations, and, is it pointing in the right direction for sun angles and things like that. Okay, what do we got next here? Biomass. So, again, the LiDAR gives us a really good view, especially with the multiple returns and the intensity and things like that, to give us a good understanding of biomass. Not just is it, are there trees around, but what's the height? How dense is, are the branches and the foliage within that, the extent. So we could typically, we could even get kind of understanding of, the width of the tree at the top versus the bottom. And, a really good, better understanding in terms of calculating, the overall biomass within a forested area. And this helps with, carbon ingestion and things like that. So, this really helps when we're trying to calculate additional things like that.
Yeah.
All right, so let's see, what do we got next here?
Oh,
Oh, there he is.
get a
I
minor
don't know
Chris,
what
I'll
happened there.
to you.
But, you always expect the unexpected when you're on a video call. So, yeah, that was weird. So, change detection. And again, I think a lot of these overlap with imagery. So there's different ways to do change detection. And, one of them, is identifying features. Another is via the elevation of features. So, we could take, year one, year two, and, if the elevation is at like 0 in year one, and now it's at, 15 feet, obviously there's a change there. And then comparing, those different aspects of the data can give us a good idea of where change has occurred. And, as we understand, the different features within the area, we can understand what has changed also, whether it's structures, whether it's just the ground, whether it's something that's within the vegetation area. So I think that's kind of the main section for LiDAR. And then I think we were going to move into our kind of combined use cases, so we could get into a little bit of that.
Yeah, I think right before that, though, Chris, I think we have a quick audience poll just to see, engage if anybody in the audience here has some thoughts on use cases that you guys have been using, products that you've been looking to create or have created using LiDAR or imagery, or if there's, something that you're interested in.
And I just launched that poll for everybody, so it should be up on your screens.
Open ended, so please, we're eager to hear what you guys are working on.
We can always let this go too, while we're kind of talking about the next couple of slides, and we can take a look at some of the answers towards the end. So if you guys want to do that, I'll leave the poll open. So go ahead and continue on.
It's a great idea. So as Chris said, we're going to talk about some combined uses. So really leveraging both imagery and LiDAR together to really get the best available end product that you can here. Chris, I'll kick it off to you for impervious.
Sure. Now, impervious is a great tool for many different uses. And impervious can be defined in different ways depending on what that specific use case is. So, some people will have paved surfaces included in that. Some people will add in structures. Some will add in things like sports fields and other kind of highly dense surfaces that will not retain water. And this might be to assist with water runoff and a storm analysis. It could be used in terms of calculating the impervious surface for parcels, and a tax rate is associated to that. The method to do this is multi-way. So one can be using the imagery, as Carson talked about, and a lot of that comes from that fourth band, helping us to understand a little bit of what the surface is, and the LiDAR are certainly going to help with that. Also, in terms of man-made structures versus the vegetation, things like that. So combining those two data sources really gives us an excellent method to create, most of what we're going to be talking about, certainly in this case, impervious.
Okay, so this is land cover derived from aerial imagery here. So on the left, you can see that this is the aerial imagery that was used, and on the right, you can see a breakdown of all of those features inside of classification. So this is a land cover classification. So you can see, waters in blue, wetlands is kind of that aquamarine color, tree canopy is your dark greens. Your buildings are your red, and then you have your impervious surfaces are gray, and they're distinct from roads themselves, which have a different return value generally. So as you can kind of see here, you have a nice, pretty nicely visualized imagery on the left here, and then on the right, you still have all that information retained, but you've lost a little bit of that texturing, a little bit of that cleanliness, a little bit when you're land covering or creating a land cover classification here from the imagery. So that's where kind of the LiDAR side of this comes into place. And Chris, I'll let you kind of explain a little bit of how that comes to be.
Yeah, sure. So, again, the LiDAR bringing into that high density data set with the elevation values and, some of the additional information returns and, the strength of return, things like that, can help and complement the data that was created via the imagery. So we could start getting into a higher fidelity type classification and, kind of get cleaner lines on a lot of things such as the buildings and, really kind of detail out a little bit better on the vegetation and, parse out a little bit of that information. One thing I will just mention kind of on a side note that, there are different ways that land cover could occur, especially when you're talking about, a classification such as this. And, if we look at like a quote top down type of a survey, you'll notice that the trees are covering quite a bit of the objects underneath. So the pathways, they overgo some of the roads and some buildings, things like that. So when our purpose is to identify and understand more of our vegetation and tree cover, we want to make sure we prioritize that. Now, maybe our priority is more of an impervious type situation, in which case we might prioritize the roads over the vegetation. So just again, different use cases can lead to slightly different visualizations of the data.
Yeah, and you can definitely notice that texturization on top of the buildings themselves. You can see all that finite infrastructure here that you don't really get on the imagery side, where it's just kind of grabbing that footprint. So. So I can talk about tree canopy change. This is something we've been doing a lot of recently, and this is utilizing both of them, both imagery and lidar here to kind of create a product. This is also using both time periods as well, which is something we haven't really talked about yet. But let's say you have imagery and or lidar from a previous 5 years, and you want to do a new round. That imagery and that data is still useful if you want to do something like a change analysis and change detection. So you have a time period from one point, and you have a time period from another point, and using those two, you can kind of see, have trees been cut down, has a development been created, have new trees grown past a certain threshold. In this case, we're generally looking at trees that are above an 8-foot level. So in here, you can see this was derived from primarily LiDAR returns here. We have a LiDAR surface model and a canopy height model. So we're basically normalizing all the terrain, so it's a flat level. And we are pulling out all of the features. So you can see in here, you can see the buildings. You can see all of the tree canopy. It's that nice like textured gradient here. And what is derived from that is we have that land cover classification that says this is a building, this is impervious, this is vegetation, this is tree canopy. And we can pull out that data. In this case, we can pull out the tree canopy. And if we do that for 2 time periods, if we have, let's say, 2020, a time period in LiDAR from that, we can gather all of the trees that are there in 2020. And then if we have another data set, let's say 2024, we can see where the trees are now in 2024. They obviously haven't moved, but some of them may have been cut down. Some of them may have grown above that 8-foot threshold. So we can kind of get a lot of information on how things are changing in this particular area of the world or of your county, wherever that may be. In the purple here, you can see no change. That means in the first period, let's say it's 2020, there was a tree here. Fast forward to 5 years later, when we do the next flyover and gather all this data, there's a tree there again, so that's no change. There has not been a change. There's a tree there in 2020. There's a tree there in 2024. Nothing has changed. You can see in orange a lot of areas that are covering what looks like suburban kind of residential neighborhoods. So what has happened is in 2020, there was a bunch of trees in this area where it's orange. In the intervening 4 years, they were cut down, and then in their place, a residential neighborhood was built. So you can see in this newer LiDAR, like this is where the forest was, this is where the new residential area is, and this is all of the trees in orange that were present in 2020 but were cut down and used to make room for this area. And then on the right, you can see all this green area. This is all trees that were probably below an 8-foot threshold, but in the 4 years since we have taken the data in 2020 and 2024, they're now above that 8-foot threshold. So now there are new trees, and we consider that new canopy. again, if you were to kind of fast forward and look at the 2020, you would see kind of all the trees on the left still present and all of the trees on the right not there yet. And then as we fast forward into this, you can see how things change. So this is a really powerful tool to kind of see how things have changed. And then you're also able to get a bunch of metrics from this, like how much, the volumetric, the count of the trees that have been removed, all this type of stuff, which is really helpful for long-term planning if you need to make any initiatives like that, or kind of just monitor the health of your ecosystem in and around your areas. It's a really powerful tool. Chris, anything you want to add there?
No, I mean, again, we can look at, like you were talking about, the elevation and kind of the volumetric study. Again, the change could be done if we were looking at the buildings, just the elevation between flat versus the structure that would now be there. So this again can be done in different ways, and targeting different types of change. So
yeah, whether it could be impervious change, it could be buildings, whatever really you want to tailor it to. If you have that land classification, you have those time periods, you're able to do that analysis. So it's a really powerful tool, and really something that you can get a lot of information out of. And that's something I kind of, before we just jump on, really just want to take a moment to highlight, that is that, maybe you guys have some of this data sitting around. You maybe did a flyover from a year or two ago, and maybe haven't used it besides just kind of looking at it for aerial reference. That's, that's great, but there's obviously a huge amount of stuff that can be utilized with existing data, especially if you grab another flyover. If you plan to do another flyover, then you have two data sets, and then you can start running change detection and things like that. So there's really a lot you can do once you start kind of building out a portfolio of different high quality imagery or LiDAR data sets. And to kind of bring that imagery back into here, how we were using imagery in this case, because this is all LiDAR derived, is that as we have teams taking a look at this to kind of, make sure that, trees are trees and buildings are buildings, it helps to have a human context. So having really, timely and up-to-date imagery is really good for helping kind of give that human context that I was talking about earlier, where, we really understand things in a visual manner. So having that is really helpful to review things like in color infrared and really see that distinction between the buildings and the trees.
yeah, and having a change map, especially in we were talking about assessors with kind of like obliques and orthos, looking at those in terms of context of year one, year two, visual inspection, having an automated change map that could be applied, can help kind of drive to the locations for those inspections. So again, a time saving type tool, as well as all the other additional benefits that you were talking about, Carson.
Awesome, great point, Chris. Chris, you want to talk about the metrics a little bit here?
Yeah, so I think the next two are kind of metrics, and again, metrics is kind of more of a summarizing some of the other data. So the tree canopy that we're talking about, we're showing a change map, but part of that is just having the actual tree canopy delineation, and being able to kind of understand, well, where do I have dense tree areas versus maybe no tree areas. So obviously if you're in a city, that's going to be low dense areas, but in your kind of suburban areas, that could vary quite greatly. So trying to understand, if your initiative is to get more greenery in, maybe that's just for offsetting carbon. Maybe it's for the health benefits of oxygenation to an area. Maybe it's to assist with mitigating runoff. All these are huge benefits for understanding, the urban tree canopy. Where does it exist, and in context of what? So, this kind of shows you, where do I have trees versus not. I think when we go to the next slide, we could kind of look at a little bit more of, how does this come into context of, kind of the heat index. So once you click over, um, so, with this is kind of showing a little bit further analysis in terms of, okay, so if we have this tree canopy data and we have, other bits of information, what can we do with that? So, one of them is, okay, where where should we be looking to kind of plant? Where's a good avenue? So the kind of on the example A there is kind of showing, where would be a good idea to be planting based on riparian buffers and, things like that. So kind of along those, rivers and streams, where am I going to get the best benefit? So like the darker greens, well, we're probably fairly well set with having our mitigation in place. But if you look kind of on the upper right there, it's very light. So probably having, a strategy to enhance the plantings in those areas might help with additional runoff mitigation, things like that. And then heat index, trees, shade, all of that, that's really helpful. So, understanding, where, you have a low index, which would be the lighter colors, that's less mitigation against heat. And again, depending on, those locations, you might want to target those areas for additional plantings to help mitigate heat, in those areas.
Just for some extra context and clarity here on the right side, the areas that are darker are more mitigated, so they have more tree canopy in their areas and they're absorbing and reflecting more heat. It kind of looks like they're burning more, but that's not the case. It's actually they're mitigating more. So
Correct.
okay.
All right, so I just threw this slide in here, so sorry to throw you off, Carson. I was looking at some of the results that people had put in for our second poll. Reminder, again, that question was, what are some use cases and products you are looking to accomplish with the imagery and LiDAR? So I kind of just put the word cloud in here just to kind of see what everybody was saying, but just to read some examples, we have drainage evaluation, pavement evaluation, flooding, mining and geology, autonomous vehicles, real estate and property management, tree analysis, flooding, change detection for new buildings and constructions and demolition. Interested to know if LiDAR can be utilized to identify obstacles when inspecting airports. For example, trees are too high, buildings are too tall, things like that.
Yes, definitely.
Yeah.
Let's throw a quick answer there. But yes, we've done many airport studies, utilizing that type of technology. So.
Identifying, not identifying, possibly to measure and count mangrove tree species. That's an interesting one. Let's see what else we got. Stormwater use cases, reviewing building permit applications, building a tree inventory, building a digital twin and extracting 3D buildings, and more canopies. So yeah, I think we had great responses. If there's anything to follow up on that you have an existing question or you want to get more information from us, certainly let us know. At the end of the presentation is our contact information. So I think you're good to continue on, Carson.
Cool. So yeah, as Rebecca kind of just showed there, I think you all have basically shown to everybody here how varied and how wide ranging all of the use cases and all the potential tools or potential problems that can be solved using this type of aerial and LiDAR imagery. So if there is something that you're interested in acquiring data for, whether that be a LiDAR flight, whether that be aerial imagery acquisition, or if you're interested in either doing that and doing feature extraction or taking existing, flyover data and doing some feature extraction for that, we're happy to help out, and you can definitely reach out to us, as Rebecca just said, and we'd be happy to get on a call and discuss it.
Yeah, we
So,
provide all those services, so we're the one-stop shop. So
So if you're interested, you can definitely contact us here or give us a ring, and we would be happy to do so. So it was wonderful to present to you all. I appreciate you all coming out here.
And if anybody has any questions they want to ask, we do still have about 5 minutes if you want to throw anything into the Q&A box down at the bottom of your Zoom panel. I had a question such as, this is not the work that I typically do, but what would be a use case for using a normalized DEM? Chris, do you know the answer to that?
Again, that type of information is, really good for identifying the features and the height of features, and that goes a long way in helping create, your canopy models and, other type feature models, identifying and, categorizing, specifically LiDAR into, structures versus, vegetation, things like that. Anything
Yeah,
to add, Carson, or?
yeah, I'm gonna just jump a little bit on that and just kind of give some visual context to it
Sure.
as well here. Um, a very good use of it is kind of cutting out a lot of this information that you may have here. So in here, you can see this is a digital service model. So it's still accounting for this large mountain that is here. So as you can see on the left, it's obviously very lower. So that's the blue. And as you go up the gradient and elevation, it becomes the yellows and then to reds as you get to the peak. In this surface model, you can see that we're still kind of retaining all of that information and that the foliage and the canopy that's down on the left-hand side is that dark blue. So it's still at a lower elevation compared to this trees that are up here. So the trees that are on this mountain are shown in red and varying colors as they descend down to the blues where they're all the way at the bottom. So that doesn't really give you a great idea of like what level those trees are. So if we kind of make a normalized model, we can see, are these trees that are on the mountain, are they the same size as the ones that are, across the river, down on the terrain floor, so to speak? Are these similar size? Are the ones on the mountain shorter? Are they taller? It looks like in this case they're actually still a little bit taller even after we've normalized all the things here. So this is a really powerful tool for kind of cutting out that noise that you get from just having a very variable terrain. It really allows you to kind of see, what is the height of that particular structure or feature, whether it's a tree, whether it's a building, whether it's a bridge, how high is that? How tall is it? What's it? All those metrics in relation to other features around, and you're really cutting out that extra information.
Perfect answer, Carson. Thank you.
Sure.
We do have one question in our Q&A box. Is there a way to identify tree species from LiDAR or imagery?
Short answer, yes. And that's going to really depend on, from the imagery side, that fourth band. And really for species, we're probably talking about more of a multispectral to really get into more of a species. Again, some of the different types of return values that you'll get out of LiDAR, could help with that also. But really that's going to be more of a multispectral to really get into any kind of detailed species type identification.
Yeah, so we had decided to kind of not discuss the multispectral analysis basically of this, but essentially there are other bands beyond, your RGB and then your near infrared, which is the fourth one we discussed. And those really can grab intensities and kind of a reflectivity and a bunch of other elements that can be used to kind of not just trees, but you could also say like, is this an igneous rock? What type of, is this like a granite? Is this a basalt rock? All this type of information. Same thing for pavement types too. Is this like a black top pavement? Is this a white top pavement? What type of pavement is it? All this type of stuff. That's kind of where you're grabbing your multispectral analysis in bands to pick up that type of stuff.
And it really helps with vegetation health, so crop health, forestry health, even just if we're looking at cropland, the type of soil and the health of that soil in terms of nitrogen and things like that. But again, that's a little bit past what we were what we were aiming at here, but
If you want to discuss it, we would be happy to do so.
Perfect. All right, well, we are at time and there are no more questions. So thank you everybody again for attending. And this webinar will be shared out for those who couldn't attend. And if there's any questions, feel free to reach out to us. So have a great day. Thank you.
Thanks, everyone.
Thank you. Bye all.